Okay, guys, we're back to weather. So on your notes here, please write the question and answer it for me. What is the difference between sleet and snow? Because I know in the wintertime, we're always wondering what we are going to get. So this is a kind of a thought question here. Feel free to pause this show here so you can write it down and then move forward. All right, so we can't do the cloud lab. I wish we could, guys. It's a really fun lab, but that is just not going to happen. All right, so let's talk about precipitation. So precipitation is going to occur when you have those little water droplets and they're hanging on to those condensation nuclei, and there's lots of them up there, so you got clouds. You know, they're not hanging perfectly, so they're not like 3 inches apart. They're actually kind of bouncing off of each other and kind of ramming into each other, especially if you have an unstable atmosphere. And when those droplets collide, they actually kind of grab onto each other and they get bigger and bigger and bigger. And finally, they get so big that gravity is going to take over and those poor little condensation nuclei cannot hold on to them. And down comes the water in the form of precipitation. What type of precipitation depends a heck of a lot what's going on in the atmosphere. So precipitation is going to include all forms of water, both liquid and solid. It could be rain, could be snow, it could be sleet, and it could be hail. Your most common form is rain, and this is just your basics here. You have the little bouncing around going on, the water droplets growing bigger, and finally gravity yanking it down, and it's just, you're above freezing temperature-wise, so everything's good, and you have rain. Sleet and snow gets a little more complicated. Sleet is rain, and when it falls through a layer of freezing air, boom, you have sleet. Snow gets a little more interesting. Snow forms when temperatures are so cold up in the cloud that water vapor, instead of going water vapor to a liquid to a solid, which is kind of a normal situation, it goes directly from a water vapor to a solid, and boom, you have snow. So it can fall as single ice crystals, or they can join together to make really pretty massive snowflakes. Freezing rain, basically it's when water falls down in the form of rain. And when it touches a really cold surface, boom, it freezes. And we all know down here in the South, when you have freezing rain, it's a very ugly thing because a lot of this stuff will freeze on those power lines or on the limbs of trees, and they fall and break the power lines, or the power lines themselves break, and then we're out of electricity for a couple of days. Hail is actually really cool too. Hail is going to form in cumulonimbus clouds as really tall, big clouds. And because they're so tall, there's a temperature differential from the bottom of the cloud to the top of the cloud. The top of the cloud is going to be cold. The bottom of the cloud is going to be warmer. And because you have a very unstable atmosphere going on, you're going to have those water droplets actually bouncing around like crazy in that cloud. And because of convection currents, you're actually going to end up having something that's warmer rise. So those warm water droplets are going to rise to the top of the cloud, and they're going to freeze up there, and then they're going to drop back down to the bottom of the cloud, and they're little teeny weeny little frozen pellets at that point. And then more water is going to wrap around that frozen pellet, and it's going to get tossed back up to the top of the cloud and freeze, and then drop down to the bottom of the cloud. And more water is going to wrap around those little frozen pellets. It's getting bigger now. Going to be tossed to the top, freezes, drops to the bottom again. More water wraps around it, gets tossed to the top, freezes, drops to the bottom. And eventually it's going to be too heavy to be carried by those updrafts, and it's going to fall to the earth in the form of hail. And you got all sorts of crazy sizes of hail there. You got your standard hail, which you kind of see around here, which is, dime size, sometimes golf ball size. But lordy, they can get big. One of the biggest on record is 7 inches wide. If you look on the bottom there, you've got one that's about the size of a softball. You can imagine the type of damage that will do. I know when I lived in Indiana, you had a lot more hail there. You had a lot more rougher weather there. And you would see after a big hailstorm, the car dealerships would have a hail sale. sale going on, and that basically means they had cars out in the parking lot and got damaged by the hail. The paint did, little chips, maybe little teeny little dents on the car, on the top of the car, so they would knock off some money so that you'd be willing to buy the car with that little bit of damage on it, so they wouldn't have to send it back and get it taken care of. All right, so we got some notes here on the water cycle. Again, I'm not going to really touch on that because God knows we have touched on it like crazy. Here's a nice pretty picture of the water cycle. Once again, we've touched on it like crazy. So we're going to look at the difference between weather and climate now, and we're going to look about heating of the earth because weather has a lot to do with that, and you really want the earth to be comfortable for you to live in. So we're going to be dealing with how weather deals with that. So meteorology, I know when I grew up it was always the weatherman, but the fancy term for it is meteorology. That is the study of atmospheric phenomena. So it's not just weather, it's all the stuff that happens in the atmosphere, and that includes like pollution, and includes global warming, all that fun stuff. The folks that do it are called meteorologists. And surprisingly, if you actually go online to like WRAL and all the weather stations, you can actually get like biographies of all your meteorologists there. And I would say most of them actually have degrees in meteorology. And some of them, I know Greg Fischel doesn't work at WRAL anymore, but he had massive amounts of work he did past his degree. He went to all sorts of conferences, got all these backups, tons of other work that he did, and tons of like little certificates with it. So these guys are actually kind of know what they're doing. It's surprising. You can always hear jokes about the weatherman being just this journalist or pretty face. No, actually these guys are not. Here's some basic instruments that are out there for you. So weather and climate are a lot of times used interchangeably when you hear the press talk about it, but they're not. Weather is what's happening like right now, or it's going to happen like in the next 5 days. So that is the current state or the near current state of the atmosphere. Climate is looking over a very long period of time, and it's the average weather. So you're looking at, you hear people moving when they retire from New York and New Jersey to North Carolina, and that's because our climate here is actually considered gentle. You're thinking, really? 95-degree temperatures, humidity, but compared to, say, New York, or compared to some of these other areas where you have wildly crazy winters, even some real pretty nasty summers, it's actually not too bad here. So it's the average weather over a long period of time. So why do we have the climate that we have here, the average type of weather? It has a lot to do with the curvature of the earth, the tilt of the earth, and where you're kind of located amongst all this. So because the earth is curved, not every area of the earth gets equal attention from the sun. So if you're at the polar regions, the rays strike the earth at very low angles, and that energy is spread over a much larger area, say, versus if you're in the around the belt of the earth, the equator, where it's a direct hit and it's not spread over a very large area. So that's a good portion of why things are like they are. Here's a nice drawing of it, so you can see why certain areas get massive amounts of heat, why other areas don't. So one of the aspects of the movement of the atmosphere is actually trying to equalize things out. If you have an area that's very cold, you're going to have the atmosphere trying to get to a place that's warm. Areas that are very warm, the atmosphere is trying to get to places that are cold. And that's why you have all this movement of air. Everything's trying to equal out. All the different densities are trying to equal out. All right, another question for you guys here. If you see a big H on the weather map, what does that mean? What is the weather going to be like for the next several days? So write this down, put your best guess, educated guess on your papers. And remember, you can pause this, no big deal, and you can continue on. So that big H has a lot to do with air masses here. And air mass is a large body of air that takes on the characteristics of wherever that air mass forms. So if it's forming in the south in the summertime, it is going to be warm air and it's going to be very moist air. If it is forming over Arizona in the summertime, it's going to be very warm air and very dry air. So wherever it's at, that's what you're going to get. So if you form over land, they tend to be drier than stuff that forms over water. We do classify air masses by warm and dry. That's your continental tropical ones. So you put the land versus water in the beginning of the of it. So C stands for continental. Anytime you see continental, that means land. If it forms over water, it's called maritime, and you would have an M there. If it's warm, T is going to be it, and it's capitalized for a reason. It's not a typo on my part. So that portion is going to be capitalized, and it'll be tropical. If it forms over a cold area, it's going to be P for polar. So warm and humid areas are maritime because it's over water, so it's going to have that moisture thing there. And tropical, if it's over land, say Canada, and it's really freaking cold in the area, it's going to be continental polar, CP. And if it's cold and humid, maritime polar. And just really cold period, Arctic. And once again, take a look at the map I have up here, because you can see here why, once again, you have those nasty tornadoes where they are. Because if you look Canada, it's cold, it's land, so it's dry. So you've got air that forms up there and comes down to the middle of the U.S. And then you have the Gulf of Mexico here, giving warm, moist air coming in. You got maritime tropical here, warm and moist air also coming in from the East Coast. And then you have, like over the Mexico area, continental tropical air masses are very dry and warm, and they all tend to sling up towards that mid area, which means, once again, different air masses meet and weather occurs, and oftentimes very aggressive weather like thunderstorms. Oops, sorry about that, guys. So what makes us a little different and why we have such a wide range of weather here is all 5 types of air masses can be found in North America. And here are the places where you can find them. Feel free to look over them. So air masses are not going to stay the same. So as an air mass, say a warm, moist air mass moves over land, it's probably going to lose some of its moisture. So it's no longer going to be warm and moist at that point, especially if it starts driving up to an area that's cold. It's going to lose its warmth too. One of the areas that are going to affect weather big time are your jet streams, which we talked about. That position, the jet stream is going to vary because remember it moves like a ribbon up and down the Earth. And weather systems generally follow the path of the jet stream. So every once in a while you hear about the meteorologists talk about a jet stream that's moving in the area, and it will play like crazy with the weather. So when you have 2 different air masses and they meet, that's where you have a front. The front is a boundary between 2 different air masses. So you hear about warm fronts and cold fronts and stationary fronts, and every once in a while, blue moon, you'll hear the term occluded front. Not too often, but it's there. These are when you have air masses that meet, and when different air masses meet, there is this little boundary area, and then they're going to fight it out. And that's going to cause some really wild weather that occurs. All right, we're going to stop here, and we'll come back next one to talk about the 4 main types of fronts, which you guys have all heard about.